Okay, now we will write this Client subsystem. This subsystem is actually quite complex, so let's first make a forward declaration. Okay, then let's see how we should do it. First, we prepare several delegates. These delegates should be very familiar to everyone. These are the delegates we used in the previous 2 chapters. You can see this, right? These are the corresponding delegates we used in the previous 2 chapters. So this is obviously the first delegate is the delegate for successful connection. Then this connection failure will trigger this delegate, and after receiving the message, after receiving the message, which delegate will it be here? Which link sent the message? And then here, we will have a time when it closes. It will pass this first piece of information. Okay, once we have these delegates, we go down to the bottom. Everyone can take another look. This is relatively simple. There's no need to waste everyone's time typing it manually. Then place it down here. We prepare a pegric. We let it bind to the delegate. We will inevitably need to prepare some pins. Not exactly pins. It's the position for binding the delegate. It must be prepared. Okay, let's compile it first, because it went a bit viral. Let's ignore it for now. Okay, no problem. With these pins in place, then obviously, we will have a container to store various collection actions. Here we need to include this. We call it our client connection header file. Let's compile again. Make sure it doesn't report errors because there is a lot of content here. Okay, let's ignore this red error for now. Let's switch over. It might auto-recognize in a moment. Now, let's take a look what methods we need to implement. First, we definitely have. Let's just list all the methods at once because they're all relatively simple. Let's not write the specific implementation yet. Let's go through them one by one. Alright, let's just go through them all at once. Let's go through them one by one. This method here, it's actually quite simple. That is to say, note that this places out. This places in, then the meaning of this method is to connect to the specified server. You need to take the URL of this website, write it in this place. Then you can create such a connection, and at the same time it tells you, the company tells you, what is the GUID of this connection, so that later you will know whether this connection was successfully created, who you are connected to. So it is him. Then on our side, certainly, you need to specify the server connection when creating. Then you certainly have to. This closes that link, such a function, and close all these WebSocket links, and then send to the server. Send the message to the server. For this method, you need to specify which link to send to the server. So this is the method we need to call. Let's create it first. These things are relatively simple. We have already written 2 chapters for you, a full 2 chapters of this process. We'll ignore these for now. Similarly, for our WebSocket, now we need to write our underlying implementation. When we create the wishing, we may need to specify these parameters. Right, then here, we definitely need to clear the specified with teeth. Note that the onLink here is different from the one here. To close this, it needs to send a message, whereas this one is very low level. It just directly kills and clears it. Clearing all connections here is very violent. If you clear it this way, the server actually doesn't know. It might only disconnect when it truly detects a heartbeat timeout. So this method cannot be used by users or other developers. Let us manage it ourselves. Okay, then let's write it like this for now. After writing it, let's go through it step by step. For the remaining methods, we'll guide you to write one and then create another. Okay, so first let's go to our first one. Initiate the connection on the specified server. First of all, we need to have it generate a GUID. This will make it easier for us to send messages later to indicate whether the connection was successful or failed. That way, the user will be aware of it. Then, after generating this ID, we use our struct, this connection struct, to declare our package connection. Of course, at this point, we don't have anything yet. So here we are. We just move this thing in. Add this link inside our container. After add, we start creating here. This is just something we wrote casually because we won't use it. So we just leave it here to show you that you can use it somewhere. Add some judgments, some authentication, investments, etc. We'll ignore it for now. Then we will actually create this breaksaw and then pass this information to next week. And inside this CreateWebSocket, let's actually execute our work. First, because I'm already used to it, I must check this module to avoid some issues. Then after checking, we go into the container to find our object. This can usually be found. Then, after finding it, we directly create a WebSocket here. This method should look familiar, right? Then we need to include the header file here. So let's go to the very top to include the header file for everyone. First, we just has several header files. Let's include them first. Then we save here. Follow our one-step action. We also need to put it here. And finally, we need to put our log and our YouTube tool here as well. Okay, let's go back to our section below. Let's go back to this CreateSocket place. Okay, so this socket of art can generally be created successfully. After successful creation, then this thing of ours must be found. That is, after we find it, we need to set this state to it, a state of long. Then we take this word chart and pass this object into it. Because it is a smart pointer. This way, we can increase its reference count to prevent it from being reclaimed. Then at this point, we bind some corresponding methods. There are quite a few methods. All of these are bound to this withdrawn method. As for these methods, you can click in to see. They are right here. Yes, you can see these methods. So like this, ConnectArrow, close and message. You should be very familiar with them, right? And then like this, and then this OnMessage sent. You're quite familiar with, you might not know why. There is an OnMessage here, because our information is handled with custom processing. So here, the actual processing of information is handled in OnMessage. It is processed inside. This place is just placed here, then we are here. To create our corresponding bound methods, there are 6 methods in total. We'll just manage them directly. You can pause here and follow along to write it. It won't affect anything. Then be created here. Okay, so these 5 methods are bound up. Next, we need to do further distribution processing. The content below might have a bit too many client parts, but you should be able to accept. And handle it, follow us step by step. Then the connection here is successful. Here we are learning to print a log. We need this log. Copy the log over. That is, we have successfully connected, but at this point, it is only successfully connected. Next, we need to proceed to this initialization phase. So we prepare a method to initialize it, but we haven't written this method yet. Haven't written it. We write this method here. This part is to initialize this connection only after we initialize the connection. Only then can we officially enter our communication phase. Let's just leave it here for now. And ignore it for now. Okay, so next we'll handle when this connection has a problem. If it fails to connect, it will appear in this place. For example, if the URL is not found or some other inexplicable issues occur, at that point, we might have no network at all. There could also be many other reasons. So in this place, we will create such a call the blueprint step by step. That means there's an error here. Did you not finish the phase? Or you wrote the key wrong or something like that. Right? Then after we close it like this, we release our resource. So how do we release the specified resource of this link value? We just need to do it here. Remove our link. Because at this time, if you release it, you can just remove it directly. Because in this link, our link, when we absorb and purchase, it will release this web chain on its own. So we don't need to manually remove this WebSocket. Because we wrap it in a layer, we wrap it into this linked form. That makes it better. Okay, after writing it like this, what do we do next? Let's go back to our connect. Let's go back to this close section. In the close section, first, we still need to print a log. The log here, this log is actually just a standard way of writing. Like this. Wrap it with a log or something. We don't need to seal it here. Let's just leave it like this, because I find the standard log clearer. And this proves that our connection has been closed. Anyway, we don't know whether it was closed by the server or the client. So first, we need to transition our connection to the quit state. We find this connection in the container and transition it to the quit state. Then we prepare an asynchronous proxy here and let it notify the blueprint in the next frame that this connection has been closed. Then we clean up our specified resources at this point. Clean up the specified resources. Okay, as for this message, we actually don't need it because we simply cannot receive the message information. So in this place, we won't use this message. If you don't believe it, let's take a look at the count. If this message is sent, actually, we don't really need it either. Because if you need it, you can modify it and then take a look at what information you actually sent out. Our focus is on better message. This part is particularly complex. Okay, before we get into the complexity, let's first refine the other things. What needs to be refined? Actually, we mainly do it here. We refine it here. That is, we still have a piece of data here. That is, because the data on our side, it is segmented into sections. So here, we need to prepare such a piece of data. This data corresponds to the link. It points to the sending, the data transmitted over the network. And then we need to take these methods above. We need to refine them accordingly. Okay, for this, let's first complete the underlying layer. When we clear the assets, we also need to clear the corresponding data. The corresponding binary data, if it is not cleared, it will cause a problem. Residual data will remain. Yes, then, if we directly clear everything, we can just handle the two things. Just remove the end. Okay, so this is the initialization. Actually, we also have a tick. Let's first add the tick framework for everyone. Then it is very obvious that when we tick during our tick, we will take on the task of performing heartbeat counting. That is the work we need to do. So here, right here, this part is especially easy to miss. We should have an onLink message here as an approach. This part is in our function. When we exit from this part, we need to implement this method. Then inside the tick, we added a method. We need to make all our links tick as well. Okay, let's link this tick, put it behind here. There are quite a few supplementary methods here. Okay, so let's first take a look in the tick link. What work do we need to do? Same as before. Remember our server, right? Let's prepare first, check if there is a link timeout. Then we directly iterate through our container. First, let the containers tick the time themselves, right? Then, as long as they finish ticking the time, then it will be let go if it times out. We quickly change its state to this. We quickly change its state to this out of time. Yes, if it times out, quickly change it to out of time. Then here, add it to our timeout. At this point, we directly, because it has already timed out, we just directly clean up its resources. Okay. So like this, we can complete our linked heartbeat. As for the heartbeat, actually, it is right here every time we tick. As long as each link reaches its heartbeat timeout, it will send this heartbeat on its own. Then before 8 times up, if it is 10 seconds, there are 3 chances to send it. But currently, our server has changed it to 30 seconds. Okay, let's come back. And then we will wait a moment and write the corresponding data processing method for this, because this is a bit more troublesome. Okay, let's also improve these few methods accordingly here. The server specified by this link of ours is already done. So how do we close this specific link? This corresponds to how we close it. Actually, it's quite simple. First, we need to print a log. This task is about closing this information. So how do we close it? First, we definitely need to find something. If we can't find it, then what are we closing? After finding it, we set this link to the pre-exit state. It's pre-exit, not exited. After setting it to the pre-exit state, because now the client is requesting the server, whether the server allows you to exit, then we prepare this information. So the status of this information is this client recruit quiet. Such a piece of information. This is what we did in the previous lesson that we simulated for everyone. We send a layer to exit. It's actually in the state. Then within this information, this ID must be the same as the IDs in this connection. These two IDs are the same. This ID must be correct. Only then can you find your corresponding item on the server. Then we just need to send it over. So that's how it's done. Exit the specified link. Then we'll comment this part out. Why comment it out? Because this requires needing to request permission from the server. Needs to know that you have exited. Only then do you need to you cannot directly release it here. That would cause problems. So what is the purpose of registering here? And if we clear all these links, it's actually relatively simple because we already prepared them. We just need to, this thing, just call it all at once. And then this registration here, we also cleared it. That doesn't matter. Okay, because in this place, it is no longer in this tick state. Then we will have, as long as we detect that it has timed out, it will be removed from our tick. Because at this point, after you switch to this state, it will be removed anyway once it times out. And then send this information to the server. It will be relatively simpler. So on our end, directly find this link. After finding the link, we prepare a WebSocket. Then this message is the client's message to server. Right, then we put these two IDs in. At the same time, we describe this message because this is the user's information, the user's communication information. Then we send it over. That's done. Then let's compile it. Basically no issues. So this is actually relatively simple. Everyone should refer to this. You can see here, when sending information here it is. For example, we send it to a specific client. This is serial message to client. Right. You see, this is pay attention to distinguish. Okay, all right. So at this point, basically our framework is written. Then the most troublesome part is that we are here. This place is initialized. Let's write it down for everyone because these are the first three handshake protocols. Otherwise, you'll miss this part. As for this initialization, it actually means we need to send an initialization message. Here, we first look for it. After finding it, we find our actual connection because at this moment, we have just successfully connected and have not yet performed any communication. This is called here when the connection is successful. We set a state here to this init server collection state, which is the client state. Look at this state. It corresponds to this state. Then after this state is returned, both of them enter this tick state, right? Then if this side is pay priority quiet, it means it requests the server. If this side is proprietary quiet, it tells the client, and only this is the final exit. It will time out. But this one is fine. Here we are preparing this information. Prepare this information. This information is a bit special. Its code equals 0. And its type is our first one. The client calls the server to perform an initialization. The server will return such information. This will be processed in our binary information. Things like this server are all processed in our client's binary information. Okay, so here we pass the client ID we created this time through the constructor. And here, for the server collection, we won't write it because we haven't yet. Because the server hasn't generated it for you yet. This server collection ID. The server hasn't given it to you yet. Right, the server should generate it. But it probably hasn't given it to you yet. You need to wait until after the first communication before you can get it. Okay, let's write this describing there is no data. Okay, so at this point, we are done. Finally we send it and it's done. Okay, so basically, this corresponding, so everyone should have an impression by now, right? This is our init saving and our tick savings. It is actually written here. You can see. Okay, so this is the tick. This is the tick savings. Yes, we were in a flurry a few lessons ago, and if we exit, this savings is written here, right here. This is the exit savings. Then our set message savings is actually this one. Our receive guard is written up to this point. Okay, these few action types have been clearly explained to everyone. Okay, so now in the next lesson, we will handle how to distribute and process the service information after it is sent over, because currently we are all actively communicating with the server. So how do we handle the information sent by the server? We will explain that shortly.